right, so I want to go over the difference between measures of variation. And so if I'm looking at this right off the bat, I know, and I want to point out that a measure of center, this is talking about things like the mean, the median, and the mode. What do all of these have in common? Well, these are all talking about where's the center, where's the middle, where's sort of that center average middle part of my data. So that's a measure of center. However, in chapter 9.4, what we're getting into is called variation, measures of variation. So think kind of variation, variety. We're now looking at things like our range, and you don't know this yet, but it's called your IQR or the MAD. You'll learn about these pretty soon, but this is talking about what is the distribution of the data? Where is all of my data? And this will kind of make sense with this next example. I want to point out the main difference between the two. So let's say you are a basketball recruiter and you want to get the best basketball players on your team. So here's player number 1. Now, for 9 games in a row, you go and scout and you watch player number 1 and you see how many baskets do they score in each of these 9 games. So player number 1, here's their results. In their first game, they score 0 points. Their second game, they score 0 points. Oh boy. Their third game, 1 point. At fourth, 1. Fifth, 1 point. Then in their sixth game, they score 2 points. Oh boy, not looking pretty good. However, here in their last 3 games, player 2 scores 10 points, 15 points, and then again, dang, 15 more points. So this is all of player number 1. This is for 9 games, how many points they score. Well, let's go ahead and compare that with player number 2. Here's where we'll say, here's player number 2. So I'm thinking, okay, is player number 2 going to be a better player to pick on my team? Well, player number 2 in their first game, they score 4 points. Their second game, they score 4 points. Their third game, they also score 4 points. In their fourth game, 5 points. And then they score 5 points, 5 points, 6 points, 6 points, and then 6 points. 6 points in their 9th game. So right now, I just want you to think, which player would you want on your team? I have player 1 who, oh boy, I don't know. But what if it was your championship game? They could either score 0 points or they might score 15 points. What are you noticing about, what's the difference about player number 2? Well, what I notice is that player number 2, okay, maybe they can't score up to 15 points, but they are a lot more consistent. So if I were to say, oh, well, let's find the average. Let's just find the average. Like each player, I'll make my decision on which player has the highest average points per game. So to find the average, or mean as we call it, I can add up all the points. So here, to find the mean, the average number of points, well, the mean would be, if I add up 0 plus 0 plus 1 plus 1 plus 1 plus 2 plus 10 plus 15 plus 15, that equals 45, and then I divide that by, that's 9 games. So 45 points in 9 games, that gives me an average of 5. So this is an average of 5 points per game. So I'm thinking that'll be nice and easy. If player 2 has a higher or lower average, that'll help me make my decision. Well, let's see what we happen to find when I see the mean here. Well, the average of player 2, if I add up all these values and I divide it by 9, that's going to, oh wow, that also equals 45 over 9. So that's super weird. So this player 2 also has an average of 5 points per game. So is that going to help us decide who the better player is? No. So this is where measures of variation have to come in handy now. Because I want to look at, well, where's the majority of the data? And where's the distribution of the data? So one way of thinking about this is there's 3 different things we'll learn, but I want to focus on the range today. Well, let's see if the range will sort of help us figure out this decision of who the better player is. So when I take the range, I want to take the largest value and subtract it from the smallest value. So the range is going to be 15 minus 0, which is 15. So there's a range of 15. And basically right now, the range will mean different things, but this is sort of talking about the range means on any given day, player number one can score all the way from 0 points to 15 points. That's a pretty big range. You kind of don't know what they're going to do. But if I look at the range, and since I'm talking about, and usually in sports you want consistent players that you can count on, I want a smaller range. And in this range, if I look, I'm going to be subtracting 6 minus 4. Well, 6 minus 4 is 2. Oops. So I have I have a range of 2. Well, which one would you want a range of? A player that could score anywhere from 0 to 15, or a player that, give or take, will only differ between 2 points? Well, considering this data, player 2 would actually be, this is your better option. This player proves to be more consistent. So even though they have the same 5 points average of points per game, they have the same average, they have a different range in values. And a smaller range is saying that, oh, these values are more consistent. What is the distribution of the data? These are all very close together. 4 and 6, 5, those are all very close together, whereas here, I'm all over the place. So this is just a brief example of how the measure of center is different from, we're going to start talking about measures of variation, and we'll get into IQ